Multisyllabic words are especially challenging for acquisition because they are less frequent, less practiced, and contain many parts. An initial meta-analysis that we conducted at UBC looked at the relationship of protracted phonological development to literacy. We found that multisyllabic words were key contexts for assessing the phonological abilities of school-aged children. There is also evidence of a developmental progression in accurate production of multisyllabic words, at least up to 7 years old. For example, Deborah James studied 230 Australian English-speaking children from 4 to 7 years old and determined that there were 2 stages of growth in accurate multisyllabic word production. In the first stage, children up to 7 years old mastered the number of syllables and sequences of consonants and vowels. After 7 years, a variety of sequences of stressed and unstressed syllables were acquired. Each time any word is produced, there can be differences in neurological activation of the components of the word, resulting in mismatches and variability across productions. Multisyllabic words have many components and thus a higher probability of mismatches and variability. This vulnerability is likely because the level of activation of one or more elements fluctuates from moment to moment and changes which elements are accessible for production. The higher probability of mismatches makes multisyllabic words important targets for phonological assessment in the school years. In fact, a recent study involving UBC and many international colleagues suggests that across languages, even at age 3 years old, there can be differences in multisyllabic word production between children with and without speech development challenges. Thus, multisyllabic words belong in assessment protocols from preschool years and become very important in early school years. We have studied typically developing English-speaking 5 to 9-year-olds who show mastery of phonology in short words. James also found that children accurately produced monosyllabic and disyllabic words with stress on the first syllable, when the words did not have complex consonant sequences or clusters. For English-speaking children, therefore, multisyllabic word assessment should include a variety of word lengths by number of feet and number of syllables, stress patterns, consonant clusters, and consonant sequences across vowels. More specifically, multisyllabic words for assessment should include disyllabic words with weak-strong stress patterns, 3 to 6 syllable words with 1 foot and 2 feet, 3 syllable words with strong weak-weak, weak-strong weak, and secondary weak-strong stress. Consonant clusters, and a variety of manner and place sequences without consonant clusters. For example, manner sequences might include nasal-nasal, liquid-glide, stop-stop, fricative-fricative, fricative-affricate, and fricative-stop. Place sequences might include labial-labial, coronal-coronal, and dorsal-coronal. Other sequences might include consonants with taps and syllabic R or L. For English-speaking children, a variety of multisyllabic words can be accessed in 2 free sources. 1. The Computerized Articulation and Phonology Evaluation System, CAPES, available free from the second author, and 2. James, 2006 dissertation. A commercial source of 12 words for screening multisyllabic word production is included in the Hodson Assessment of Phonological Processes, 3rd edition, HAP 3. Once we have a set of multisyllabic word productions for a child, what do? There is currently no evidence-based method for analyzing phonological production of multisyllabic words. Current analysis tools do not account for all levels of the phonological hierarchy. The development of a valid multisyllabic word analysis procedure needs a theoretical basis in both linguistics and language processing. In our approach, we have considered 3 theoretical models: nonlinear phonology, language processing, and interpretations of brain activation patterns. All of these sources support the idea that multisyllabic word production is an interactive process involving multiple levels of linguistic structure at the same time. Another key aspect of language processing and brain activation explanations is the idea that lexical access, or word selection, is an integral part of phonological production. This is because words are presumed organized or connected through word neighborhoods. Word neighborhoods can be thought of as connections among words with similar components, such as an initial consonant or a complete rhyme. The next section presents a current multisyllabic word analysis method being developed at UBC. The analysis tallies the distributed effect of mismatches across multiple phonological elements, including lexical selection, feet, syllables, consonant and vowel timing units, and segments and features. When examining child data, a clinician can look at it from the point of view of relative accuracy or from the point of view of errors or mismatches. The advantage of accuracy measures is the attention to the positive. Measures of this type have focused on accuracy of word components, for example, correct number of syllables, consonants, or vowels, and the correctness of consonants or vowels. In some methods, accuracy scoring is confused, however, because segment insertions are ignored, or points are later deducted for insertions or deletions. In other cases, accuracy scores for various word components have been weighted, but assigning weights to levels of phonological representation is very challenging and is still arbitrary. Simple tallies seem to tell the story. Clinicians often compare client productions with the adult targets, with a view to describing the differences. Advantages to this framework include consistency in quantifying phonological production, as opposed to a mixture of matches and mismatches. Another advantage is that there is no assumption of an absolute value of correctness, or the degree of accuracy compared to an absolute. Another important advantage is that by having an understanding of mismatch patterns, a clinician is able to select strategic goals for therapy. So, in the UBC analysis, we tally phonological mismatches. One tally is assigned per mismatch across each phonological element: lexical selection, foot, syllable, consonant and vowel timing unit, segment and feature. Consonant features are tallied in terms of place, manner, and voicing, and vowel features are tallied for height, backness, and tenseness, but also roundness if needed. In making decisions about mismatches, Major phonological patterns are considered within a language processing framework. Deletion, insertion, which clinicians often refer to as addition, reduplication, metathesis, transposition, assimilation, and substitution. An additional category, lexical influence, is also tallied because this level is included in language processing models of phonological production, as we explained earlier. We will demonstrate judgments of lexical influence in some tally procedure examples later on. As we progress through explaining the UBC multisyllabic word tally procedure, you might think that the approach to identifying processes for multisyllabic words is different from more traditional definitions. This is because we attempt to take into account how language processing models help refine these definitions. Even though we do not yet have norms for these tallies, criteria reference data are currently being analyzed for typical 5- and 8-year-olds and compared with data from children with protracted phonological development. While we wait for the results, our method is presented here so that clinicians have some new ways of examining longer words with all of their complexities. At UBC, we have been tallying mismatches in multisyllabic word production by displaying the hierarchical levels of each particular elicited word in spreadsheet rows. We use the columns to enter our tallies. The example here shows the organization of the word hippopotamus. Because we are interested in comparing the way in which all of our participants have produced hippopotamus, we have organized our sheets by this word, and so the sheet is labeled as hippopotamus on the Spreadsheet tab. Alternatively, you might label one sheet with the name of a child whose phonological data you wish to analyze, and enter all of the words spoken by the child on the same sheet. Let's look across the columns so we can see how the format of the tally sheet is set up. We have deleted columns A through G to take away confidential child identification information. We'll begin with columns H and J. In row 1, we have information about the target production for the word. The target is transcribed in IPA. In the cells underneath the target, we enter the child's actual production of the word, also transcribed in IPA. Moving to the right, in the first 3 rows of columns K through AP, we have information about the types of mismatches that are tallied and a breakdown of the target word into its component parts. In row 1, there is a section of color-coded mismatch types that are possible at each level of the phonological hierarchy. Examples in columns P through R show insertion, deletion, and reduplication, which we have abbreviated here. We are using the color coding to study the types of mismatches children use, but you do not need to use them unless you really want to. Simply tallying the mismatches gives lots of information about the child's ability to say multisyllabic words. We have left the color codes in the sheet so that you can refer to them while we talk about the tallies as we go along. Returning to columns K and L, row 2 indicates that in these columns we tally judgments of lexical effects. Lexical effects is the term we are using for lexical selection influences from word neighborhoods. We talked about word neighborhoods earlier when we explained language processing theories. For the word hippopotamus, we have 2 columns for lexical effects because there are 2 feet in this word, shown in row 3. In our research, we have noticed that there can be lexical effects in one or both feet, probably because there is a syllable in each foot that is relatively more stressed than the others. We were also interested in finding out if a particular foot is more susceptible to lexical effects. For clinical purposes, having the two columns for lexical effects will not affect the number of tallies at this level. Let's move on to columns M through O. This is the level of stress pattern, which is the pattern of the amount of emphasis on each syllable. Linguists call this the level of prominence instead of emphasis. As we just mentioned, the word hippopotamus has a relatively more stressed syllable in each foot, and one or more syllables with weaker stress. So each foot has its own stress pattern of stronger and more weakly stressed syllables. We have shown the feet again in row 3 just to keep track of what those are. When the feet are combined, the whole word has a stress pattern. Thus, we have 3 columns for stress pattern for this word, one for each foot and one for the whole word. Columns P through T form the next section of the sheet and refer to the number of syllables in the word. For hippopotamus, there are 5 syllables and therefore 5 columns. Row 3 shows each syllable in the word in its IPA notation. Moving further to the right, columns U through Z show the timing units for the word. We can think of those as the number of consonants and vowels. Another way to think about timing units is as slots that consonants and vowels get selected for. In row 2 of columns U through Z, there is a reminder that timing units can also be thought of in terms of the onset, nucleus, and coda of a syllable. Just to refresh our memories, the onset includes any consonant segments preceding the vowel. The nucleus refers to the vowel, and the coda includes any consonant segments following the vowel. These notions can be of help in deciding which of the color codes might apply to a mismatch. But you don't have to worry about components other than consonants and vowels unless you really want to. In the timing unit section, we don't tally for whether or not a consonant or vowel is a mismatch because one or more features mismatch. But we do tally if there is an incorrect number of consonants or vowels. Mismatches of consonant or vowel features are tallied in the next section of the spreadsheet. Again, just so we know where to put tallies, in row 3 we have entered the IPA symbols for each of the segments. That brings us to columns AF through AP, the section where segment feature mismatches are tallied. Here again, in row 3, we have entered the IPA symbols for each of the segments. For the most part, we tally the main features of manner, place, and voice. Sometimes, certain diacritics in the transcription pertain to the tallies for features, but tallying diacritics will depend on whether you use them in your transcriptions. If you want to use the tally system for comparing analyses of multisyllabic word production, you will have to be consistent about whether or not you use diacritics when you transcribe. At the very end of the sheet are columns AQ to AT, the columns for totaling the number of tallies. In column AT, you can keep it simple and just calculate the total number of tallies across the whole word. Otherwise, there are also 3 subtotals available in columns AQ, AR, and AS. If you want to summarize the number of tallies for subsets of your data, you can subtotal all of the lexical effect tallies in column AQ. In column AR, word structure tallies can be subtotaled. Word structure includes several levels between columns M and AE. Those levels are stress pattern, number of syllables, and number of timing units. The third subtotal is for feature tallies, made in columns AF through AP. Now that we've covered an overview of the spreadsheet setup, let's carry on and practice analyzing a word. A good starting multisyllabic word example is the word we have been looking at in our demonstration spreadsheet, hippopotamus, because it is a long word with quite simple sequences of consonants and vowels. Because word structure insertions or deletions can have significant effects on intelligibility, the tallies tend to compound from level to level. For example, let's look at the first foot, hippa, produced by child 2. The missing schwa vowel after the p means that there is a mismatch for the stress pattern of that foot and for the whole word. We give a tally for each of those mismatches in columns M and O. We also give a tally for the syllable deletion that the missing schwa causes. The tally is in column Q. That then means the timing unit of the schwa also gets a tally in column X. In column AI, all of the vowel features of the schwa are missing, so we tally 3, 1 each for height, backness, and tenseness. In this case, roundness is not needed. The deletion of that schwa has been tallied across all levels of the hierarchy. Insertions are tallied in a parallel way. This way of compounding tallies has helped us distinguish between the severity of children's total word tallies, where tallies were equivalent, using other accuracy scoring methods. Now that we've covered an overview of the spreadsheet setup, let's carry on and practice the comparison of the productions between Child 1 and Child 2. We'll start with our judgments of lexical influences. Judgments of lexical influences are somewhat subjective, but because of the language processing model we're using, we felt they were important to include. In Child 1's production of hippopotamus, foot 1 has a change in the vowel. Many English-speaking children shorten the word hippopotamus to hippo. We've made an arbitrary decision with our tally procedure that we will still count this as a lexical effect when the whole word needs to be produced. Therefore, we have put 1 tally in column K. Moving to Child 2, the production of hit, pometh, we have again made a judgment that the first syllable hit could have the lexical effect from the monosyllabic word in English, hit. It's worth noting that many monosyllabic words in English can also serve as a syllable in a multisyllabic word, and so we consider that these monosyllabic words and syllables are connected in their word neighborhoods. We next make our judgments about the stress pattern in these productions. In Child 1's production, all stress patterns have been produced correctly, so there are no tallies. In Child 2, the production of hit pomus has resulted in deletions. In the first foot, the schwa is deleted, and in the second foot, the whole syllable da is deleted. When we have deletions that include vowels, we always will score a tally for the stress pattern because stress pattern is automatically affected. Child 2 had a stress pattern change in the first foot and the second foot, and so we tally an extra tally in the stress for the whole word. We then move on to the number of syllables. In row 1, you see the color-coded categories that we might use for the types of processes occurring in certain productions. We are not using all of them in this example, but we do have examples of deletion again. So for child 2, the deletion of the schwa in the first foot means that that syllable has also been deleted. And as we mentioned previously, in foot 2, the whole syllable da has been deleted. So there is a tally for each of those. The next level concerns our timing units, which are the number of consonants and vowels produced. Again, we have a number of different color codes for this section of the spreadsheet, but we will not talk about those in detail unless they are applicable to making the judgment of where to put a tally. In Child 1's production of hippopotamus, we have tallied a 1 for the insertion of the extra vowel where the schwa should be, creating an extra vowel timing unit. For child 2, we have the opposite situation where the deletion of vowels has resulted in a tally for each vowel, and in the case of the syllable deletion, a tally for the tap. The final section of the spreadsheet concerns segments and features. In the first child's production of hippopotamus, we have tallied 3 tallies for the insertion of the 3 features in the new vowel We've chosen to ignore changes in any further way with regard to the schwa because of the automatic transcription of the vowel O in English, at least for the Canadian-speaking dialect, as a diphthong. As we move across to the tap, we see that the tap looks as if it has been replaced by an n, but because there is an in the last syllable of the word, and the 2 consonants share the nasal feature, we are coding 1 tally simply for the reduplication of the nasal feature. We are judging that the place for the n is roughly the same as for the tap, because by default the nasalization has created the n. A simple tally at the end of the word for this pertains to the diacritic of dentalization. In some cases, clinicians would likely transcribe a substituted voiceless th, and this would also mean 1 tally for the change in place of producing that consonant. When we look at child 2, there are also 3 tallies for the schwa in the first foot, but this time the tallies pertain to deletions. Similarly, we have 3 tallies for the deletion of 3 features for the tap and 3 features for the schwa. Similar to child 1, child 2 has also received a tally for the dentalization of the S. Now we arrive at the end of our spreadsheet where we have our subtotals and totals of tallies for the children's productions. In column AQ, we see the lexical effect subtotal for each of the productions, which were both 1 because of the changes in the first foot of the word. For child 1, There was only one structural tally, and that concerned the insertion of the vowel timing unit. However, child 2 had 8 mismatches in the structural components of the word. For child 1, looking at feature subtotal, we had given this child 5 tallies, whereas child 2 has 10 tallies. Now we can compare the overall totals between the children, and we have the difference between 7 and 19. Given that child 2 has made so many deletions in their production of the word hippopotamus, this seems to convey the distinction through the difference in these total amounts. So now you can go on and practice using the rubric or the tally system using this version that child 3 produced, hippopotamus. And when you're finished, you can compare what you have tallied with our answer key. Now we'll give an example of the analysis procedure for a shorter word with a number of complex consonant sequences. This time the word is explodes. Child 1 has produced the word as spalodes, while child 2 has produced the word as gusblows. We have decided that neither of those productions has lexical effects. When we move to stress patterns, we see that both children have 2 syllables where the primary stress is on the second syllable, as it should be. So we have not coded any tallies for stress changes. Moving on to the syllables, once again, both children have produced 2 syllables, and so we have not tallied any mismatches for the number of syllables in this section. In terms of the timing unit sequences, now things get a little more interesting. And this is a section where the particular mismatches the children have made could seem a bit confusing. However, if you think of the vowel as being the nucleus or the center of the syllable, it's possible that the way we have tallied the mismatches will make more sense. Child 1 has maintained both syllables, and for that reason has a vowel in each syllable. We have transcribed I as the target vowel in the first syllable. However, in spoken conversational English, it's quite as likely that that vowel would be produced as a schwa. So we have not tallied any loss of timing unit for any vowels, even though we see a schwa there. Instead, what we have decided is that the s and the p from the cluster in the second syllable have metathesized around the first vowel in the first syllable, leaving us with spalodes. Child 2 has done something similar, except that the child has maintained the k segment and metathesized it around the schwa vowel. So we have given 1 tally for that child's change to the timing unit structure of the word. At the end of child 2's production, there is a deletion of a consonant timing unit because we do not see a d present, and so that child has received another tally for the loss of that consonant timing unit. Moving to the segments, we made a judgment that when there was the metathesis of the sp to the front of the word, that the k timing unit was actually preserved. However, the features of the k do not appear, and so we have tallied 3 tallies for the deletion of those features. And there are no other feature mismatches in that child's production. For the child's production of Gus blows, the K seems to have acquired the voicing feature, and thus we see a G. Therefore, we are tallying one mismatch in voicing. In our color coding, we are considering this to actually be an assimilation of the voicing or the laryngeal feature, because there are other voiced consonants at the end of the word. The reason we have decided this is an assimilation is because these are children whose productions of short words showed that they could produce all the consonants of English correctly. So it does not, in our mind, show that the child has a consonant substitution per se, but in all the complexities of the language processing that goes on to produce the word, voicing has also been assigned to this consonant. Finally, at the end of the word, we tally 3 deletions for the features of D, which are missing. When we look at our subtotal columns now, we see that neither child had any mismatches for lexical effects. Both have 2 tallies for structural changes. And in the mismatch of features, the first child had 3 tallies given, while the second had 4. And so we see a difference in the total of the mismatch tallies between 5 and 6, which is not a great distance. And when you look at the difference in the 2 productions, in a subjective judgment, they seem to be relatively close together. So these tallies are perhaps a fairly good estimate of the difference between the productions. Once again, we've provided a practice example of a production of splodge for explodes, and you can again practice and then check your tallies with our key.